Thanks for coming tonight. I suppose the inspiration comes from my love of food, but also for the fact that in the last 2.5 years that I have been in private practice, I've realised how deficient some of my medical training was. And I realised that we got no training in regards to nutrition, no training in regards to lifestyle medicine. And I think there need to be some really serious changes out there in the medical school curriculums. Being here, you're obviously, practicing some form of integrative medicine. And I hope at the level of a subspecialist like me, that maybe one day we will be better at working together with nutritionists, Chinese medicine practitioners. But there is a big roadblock there. I do think it needs to change. Everyone knows these guys, Watson and Crick, 50s. So it's only pretty recently in the history of medicine that, we discovered DNA. And it's just amazing in this time frame up until today what we've learnt about ourselves. Does anyone recall what happened in the year 2000? Yeah, the Human Genome Project, excellent. And telling the world that they had finally finalised the Human Genome Project and that it could never be patented. And I really love this quote. It's the entire human genome, without a doubt the most important, most wondrous map ever produced by humankind. A huge part of the Human Genome Project was the evolution in knowing what we know about genes, and that is epigenetics. Epigenetics, so it's a Greek word. Epi in Greek means on top of, okay? So epigenetics means it's basically above genetics, okay? So it literally means on top of genetics and refers to processes that induce heritable changes in gene expression without altering the gene sequence, okay? So your gene sequence, that karyotype is fixed, but the way it expresses itself is not. I like this definition. The genome is the hardware and epigenetics is the software. I really like this diagram because it really simplifies 2 out of the 3 known epigenetic changes that we have discovered. So you can imagine this is a bit of DNA unravelled. The me at the top signifies methylation. When you put a methyl group on a bit of DNA, you can either switch on or switch off a gene expression, but you're usually switching it off. Okay? So what have we got here? Can anyone tell me what they see? I think this is the most beautiful, simple example of epigenetics that I've ever read or come to know. So you've got 2 larvae, 2 bees, 2 soon-to-be bees, okay? And we all know that we've got your worker bee, your drone bee, your queen bee, okay? They're all genetically the same. But how is it that the queen bee is bigger, she reproduces, she has certain trays, she kills other queen bees, she rules the roost, so to speak. And why is the worker infertile and lives a lot less than a queen bee does? This is epigenetics, okay? So what happens is, for the first 3 days, they're both fed royal jelly. They're fed royal jelly made by the worker, okay, for the first 3 days. The difference is the queen bee gets fed an extra 3 days of royal jelly, and that turns on DNA methylation. Okay, so what happens then is she has a certain gene that is repressed, and then what happens, her phenotype completely changes, even though her genotype is exactly the same. So this really is the most basic example what epigenetics is. What I like about epigenetics is that it allows us to understand how diet can prevent or cause disease. It allows us to explain to our patients how their diet can prevent and cause disease in themselves and future generations. So it's basically being accountable for future generations. Anyone heard of Pottinger? Pottinger's cats? Pottinger was, I think he was an endocrinologist in the States in the 1930s, worked a lot in TB. He followed 4 generations of cats, fed one group raw food, raw milk, and the other cooked food and heated milk. And he found that the animals that were fed cooked or heated up food didn't do as well over the generations, and they suffered more diseases, more infections, didn't live as long. And I think he had a big part to play in the raw food movement. His conclusion from his studies, physical degeneration caused by a poor diet in the mother is inherited in the offspring and passed on through the 3rd generation. This is what he saw. When a mother's diet is nutritious, not only does she benefit from good health, so too do her offspring and their offspring and so on. And working in fertility, I think this is really important for me, and I think that's partly why I'm so passionate about it. Epigenetics is empowering. So when I see a woman who's 40 years of age, she has no control over age, 0%. But if she's overweight, she has hypertension, she has diabetes, well, she may be able to try and reverse some of those changes in what she does in her lifestyle. Anyone heard of the Agouti mouse? But what happens is these mice have an Agouti gene and it's expressed, and as a result of that they develop big coats and yellow coats. They're obese and they develop cancer and obesity and they die early. So you have here 2 Agouti pregnant. You've got one that's fed a diet rich in vitamin B and one that's standard diet, fed a standard diet, no added vitamin B. What happens? DNA methylation occurs, and in moving down, the pregnant Agouti mice that is fed the B, DNA methylation switches off, and you have this. He has a baby that's completely normal. So our health is not only determined by what we eat, but also by what our parents ate. This was a study that was published in an endocrine journal in the States. They thought, well, you know what? We think that oocytes, eggs, are susceptible to periods of hyperglycemia. And we are going to assess what are the effects of sugar intake on the egg before fertilisation in healthy, non-obese women. Their hypothesis was that sugar inhibits egg maturation and development in the early embryo. What they did was they took a control group and another group, a sucrose treatment group. So what they did was they fed them the typical Western diet, and in the sucrose group they added what would be just the average amount of sucrose an average American woman would have in her diet on a daily basis, so not too much, and they were non-obese. They put these monkeys through ovarian stimulation. They then triggered them, did an egg collection, and then looked at the egg quality. And then they looked at the outcomes. So we always look for ovarian follicle development, what was the maturation at the level of the egg, and what were the embryos doing. They found there were no differences between the groups in terms of menstrual cycle, body mass. So those that had sucrose did not gain weight. The progesterone levels and the number of eggs recovered. And they found there were statistically significant differences, quite significant. I haven't put in any p-values there or CI, but I apologise for that. Sucrose versus control respectively. So M2 means mature oocyte. That's what M2 means. In kind of IVF lab terms, when you say M2, you know it's a mature egg. And there were significant differences in fertilisation. But there were no significant differences in progress to blastocysts. So they concluded that dietary sugar consumption has profound consequences on the egg and pre-implantation embryo. And I brought this up at a doctor's meeting and asked people, would you do the same? Would you tell your patients, look, go on for 6 months and cut out sugar? And so, no, you can't quit sugar, it's too hard. It's too hard, you can't say that to patients. I don't know. Our DNA and destiny really does lie in our lifestyle. And obviously environment, and that could be, what kind of environment do you surround yourself in when you're eating a meal? Are you surrounding yourself around people you don't like? Are you taking your time to think about the food that you're eating? Are you eating out on the street, or when I show you later, are you eating on the Greek island, which really changes the way you eat your food? So you shouldn't be stressed when you're eating food, because then obviously certain gut hormones will be released then, which then will interfere with the normal absorption of food. This is, I'm pretty sure it's Ikaria, which is an island in Greece. It's in one of the blue zones. Has anyone heard of the blue zones? Yeah, so I think there's one in Costa Rica, Sardinia, certain areas in the world where people live a very long time. And there are scientists that just live there full time studying these people and trying to find out why it is that they live a long time. And it's really because, this is a picture I took of an older man in Santorini recently. Perfect example of healthy living. So he lives on an island with his family, his extended family. He's in his 80s, doesn't have any single medical conditions apart from hearing. He can't hear very well. A great community feel. Everything's organic, it's eaten fresh. And when you eat, it's a joy, it really is. And I think in all of this, it's important to remember primary foods. So you can think of foods, what we're eating today is secondary food, but primarily, foods like healthy relationships, a good career, frequent exercise, and whatever spirituality you may want to follow is also important. So we often forget that that is a type of food. So some concluding remarks, so we can eat more food. I think most of what we've heard today is good news. That through epigenetics, we are realising that the effects of poor diet are much worse than we ever realised. Diet enables genes to either express or suppress illness, okay? So I think we need to tell patients that. Our genes remember how they've been treated, so you insult them and they'll insult you back. Foods and other substances that mothers and fathers consume, potential future parents, can affect not only their own health but can also be detrimental to their offspring. And it is the responsibility of our patients to eat well if they want to create healthy babies. That's it. And I love this. This is by a Swedish epigeneticist. We are not victims of our genes, but rather our genes are a victim of us. Shakespeare also said this, but in a different way. The fault is not in our stars, but in ourselves. So I ask you, what message are you sending to your genes on a daily basis? And maybe asking our patients that too. I hope you enjoyed my talk. Thank you.